Good evening, Middle East and Asia Pacific. Good afternoon, Europe and Africa. And good morning, America. Welcome to our TaiyangNews Solar Module Innovation Conference, which is organized like usual by our team based in India, China, and Germany. My name is Michael Schmela. I'm the Managing Director of TaiyangNews. If you don't know us, we're a solar news platform which is focusing primarily on technology. The Solar Module Innovations Conference, subtitled for Buildings and Utility Scale Power Plant Applications, is one of our flagship events. And thanks a lot to all our sponsors, which help so that we can keep our events free of charge. So if you enjoy our events and free reports, you are invited to sponsor the events as well. Please get in touch with us. We have close to 700 registrations from around the world for this two-day event, and many of the main stakeholders in the large field of solar modules have at least registered, and I hope they also attend. Like usual, also a few words on housekeeping. So we try to keep our events very simple. That's why we use Zoom. Please use the chat room function, not only to ask questions to the presenters, but simply use it also as a tool to communicate to each other. Although this is a digital event, we try to keep it as active and proactive as possible. So please feel as if you were sometimes also in a coffee room and chat with anyone you want around publicly. As this is a non-moderated chat area, please keep the netiquette and be always nice with your comments, even if you don't agree, maybe because the other one is a competitor. Nevertheless, please stick to the rules. Okay, so scientists in research institutes, also with material suppliers and module manufacturers, have been particularly innovative in recent years. That's why we chose that name, and enabling quite a jump in module efficiency, cell modules and efficiencies, and also a drop in final LCOEs. And that spans actually not only from the lowest cost power plants applications, but also to building attached and also building integrated systems, which are very much a niche today. Has been in the past and still is. But, and here comes the bit, but the flexibility and versatility of solar modules is a crucial key to the success of our technology. And that's why, with the decreasing costs and all these innovations, we will also sooner or later conquer all these different and smaller applications that are all out there. So, and that's also the reason why there's so much out there that we are organizing a two-day event. On day one, today, we will look at the latest development in the building segment, from residential rooftop to commercial and BIPV. And on the second day, we will focus on module technology progress in ground-mounted power plants. So as it takes, like in a kitchen, also in our case, several contributors to make a great product, we have not only invited module manufacturers, but also representatives from research institutes, process materials. And tomorrow we will also have a developer, EPC, IPP, participate. Just a quick glance at what we can expect today. So we begin with an opening presentation from Professor Gottschalg of Fraunhofer CSP, who will share trends on PV module and impact on reliability and durability because innovations are obviously one thing, but reliability and durability, we cannot emphasize enough. And this has to go obviously in line with this. Fraunhofer CSP's expertise is a lot in that field, and so we're happy to have Ralf Gottschalg talk about this. Afterwards, we will delve into presentations from module and material manufacturers who will address different technologies for rooftop applications. So we have, happy about that, Jinko looking into BIPV. Haven't seen any such presentation from Jinko before. We have Jollywood addressing C&I applications with their high efficiency TopCon products, and Astronergy providing background on their new steel-based solar modules. As sustainability and recycling will become more and more important for solar, especially if we not only deploy but also get some modules out of the circle. We are also very happy to have with Covem a backsheet manufacturer that has developed a product for closed loop recycling. And at the end, a highlight of this event for me will be the interview with solar pioneer Dr. Shengrong Shi on the potential of BIPV, where we want to discuss opportunities and challenges of this niche segment. Okay, long introduction. Let's start. The first presenter is Professor Ralf Gottschalg. He's the director of the Fraunhofer Center for Silicon Photovoltaics, which he leads since 2018. He's also a professor of photovoltaic energy systems at Anhalt University in Eastern Germany. And before that, Ralf was the professor of applied PV at Loughborough University in the UK. Ralf, very happy to have you with us for the first time. The floor is yours.
Okay, I can't share my screen. Now I can. Okay, good. Okay. That should be, the screen should be shared, and you should have also a video of my, no, video don't. Okay. Video I can't share because the host has stopped it. Okay. Thank you very much, Michael, for the kind introduction, and thank you very much for having me. You asked me to talk about the trends in PV modules, and I replied back, yes, I can do that, and the innovation in that as well. But for me personally, I feel very strongly that if you don't talk about reliability or durability, then you, well, miss half the story, because, well, I'm a bit of a burnt child, as you say, because I did my master's and my PhD in amorphous silicon, and we all know that degradation was maybe one of the Achilles heels of that technology, so I'm a bit oversensitive maybe. So, but first of all, just let me allow me to say 2 or 3 words about the Fraunhofer CSP. We're part of the Fraunhofer Society, where our big cousin is the Fraunhofer ISE in Freiburg. We are a smaller institute or a smaller group. We've been founded as a satellite between the Fraunhofer ISE in Freiburg and a microstructural and materials institute here in Halle, Saale, which is in Eastern Germany. The strength here is largely on micro and nano analysis and diagnostics, and fault identification in materials. So we've inherited that strength, and I hope also a little bit of an understanding of solar energy systems from Freiburg. We have 2 locations. One is here, the building I've shown you in the beginning. That's our center here in Halle. And we have a commercial module line out in Schkopau, which is a smallish town around the outskirts here, a former chemical park, as you have some in Eastern Germany. Our main focus here is to talk about quality assurance and to talk about through the value chain. We talk about root cause analysis of semiconductor-based failures, or, well, a failure in this case could also be named a patent issue, where I believe some have been shown recently, especially if you have a stack patented in the semiconductor, we're quite capable of identifying if it could breach or not breach the patent. We deal a lot with materials reliability. Also, my background is lifetime assessment of materials, and we come more and more into the lifetime or warranty rate prediction, which is a key topic I think we're missing, and technology and process analysis. So what I want to talk about is why mention reliability and durability in the same sentence. I think I made a point of that, but I'll just emphasize that again. I talk about some innovations in the utility scale PV, some of them BIPV, but I also think a lot of interesting things are happening in new applications, and I'll talk about that as well. So in the first part, why do I mention it? I'm a research institute. I have a personal interest in reliability, so I would always highlight this point. But I find this slide on the right, or the graph on the right, I find very interesting, which is sort of the balance sheet information of a tier 1 manufacturer. I think they still are, or they may not be, I don't know. But this is the annual warranty return rates. And the warranty return rates just also always are reasonably close to 0.35, as most manufacturers report that. But then you see sort of the big blips you have. And these are all down, I believe, to innovations, either innovation in the process cycle or in the product material BOM, or I believe the last one, the 2018 to 19 blip, is down to contacting, or I think so. I don't know, but I've always wanted to say there is a real risk of innovations going wrong. And if my accrual rate is lower than my warranty returns, then I financially have a little bit of a problem. The biggest driver for innovation over the last decades has been cost reduction. I still think this is the key, what we're after. But I think also reliability and durability is making a much larger contribution to the cost of energy, which is for me personally the main issue we're after, than people really would like to admit. So unfortunately, it carries a risk. And modern modules may or may not be more reliable or less reliable. There's a couple of statements which state that recent innovations have not resulted in increased reliability. Others would think so as well. I'm just putting one statement out here just because I'm a little bit of a moaning myrtle. I tend to see more problems in the field over the last years. And that is partially because we have a little bit of a change in materials, we have a change of technologies, and I want to talk about a little bit what that means in reality. So first, let's start looking at the utility scale, which is 90% of the market, and that's the most important one for us. Trends which I've seen over the last 18 months or so is certainly a power rating going up to very large module ratings, which means, from my point of view, very large modules. We had that in the past with amorphous silicon, where we had a 5 square meter module, and that had a fair number of issues, not because it was amorphous silicon, just because it was as large. And I think this we'll see here again. We have increasing cell size, which is partially responsible for an increase in module sizes, but also this is a major issue here. And we have a new contact schemes, which I talk about in a bit. What I see as a new standard, modules tend to be bifacial. The number of bus bars has limited itself again to some sort of 2 or 3 options. Most cells are at the moment half cells, half cut cells. So that I don't talk about in the innovation sector. What I see as astonishing from my point of view over the last years is really the increase in cell size. I say astonishing, it's not maybe impossible to predict the speed with which this has happened. On the top right, there's sort of the typical learning curve at some stage shown, and then a colleague here, Christoph Erban from Sunnovation, drew in sort of when new wafers have been introduced. And we just see we had some 20 years or thereabout with 4-inch cells, then maybe 9 years, 10 years with where 5-inch cells were sort of dominant, then 6-inch cells. And now you can see these increasing speed and innovation of new wafers and so on, wafer sizes, up to the M12, which is 4.5 times the good old 4-inch wafers. What I also find astonishing really is if you look at the technology forecast from the agri-PV, which forecast in 2019 that we would have M6 wafers more or less being dominant by 2027 or so, when we have more than 50% of M6 wafers. And there was, and larger, but there wasn't really a large distinction between anything larger than that. If you then look at the 2021 results, okay, this is for 2020, they were published in April 2021. You can see that, apologies, that has shifted, by the way, with this font size there. The M6 is now, well, not making that much of an impact anymore. It maxes out maybe at 30%. But by 2027, or call it 2028 here, it's actually already declining again compared to M10 or M12. Again, this is not my forecast, that is sort of the agri-PV. And I think this is pretty astonishing, but also from my point of view, being a reliability and quality guy, this has some feedback and loop to the reliability. The cell size is not changing the cell physics a lot, but it changes from my point of view the thermomechanical behavior of a module. And that means I'll get a whole zoo of different effects. Another thing which has come up, maybe just had a little bit of a hype in the beginning of the year. It looks a little bit calmer at the moment. But we play around with the gaps between the cells. We have a typical spacing of 2 to 5 millimeter. We used to have that as the standard. Then we just went to larger, to smaller gaps. Then we started paving, which is a different type of ribbon. Again, how does that fatigue is a good question. I don't know, but I would be interested in learning. Then we came to zero gap and then to shingled gaps. With all these innovations, we aim to increase the active cell area. But we also change our manufacturing methods. So we go from a classical stringing process for the top 3, where with a zero gap and the shingle cells, we might end up with a pick and place process, which again has different challenges. We move from classical soldering to something which is an electronic conducting adhesive, ECA. And we have an interesting behavior in terms of thermomechanical expansion and fatiguing. Sounds a little bit boring in a session around innovation, but keeping in mind that if you look at the failure statistics in, let's say, Arizona, and you look at 20-year-old modules, you will find that the major failure mode you see after 20 years is actually fatiguing of the contacts and the ribbons and so on. So what happens to a completely new contacting scheme like ECA after 20 years? For me, it's an open question. And I don't think we have at the moment, or not, I don't think, I'm absolutely certain we don't have the tests for that yet. And there will be the odd surprise in the making. So it will have an impact on reliability, but also on durability. In terms of durability means for me an accelerated aging reduction. From my point of view, well, we cannot really predict our aging prediction. So past has shown that we're somewhere around 0.4 to 0.5% per year degradation rate. And we now see some modules which claim to be 0.2, 0.25% per year degradation rate. How that is proven, I don't know, because I see that as a failure which accelerates. So it doesn't start in the beginning. It's very static to a certain point, and then all of a sudden the failure mode develops, and then you start crashing pretty much. So, so that is worrying. We also have new cell technologies coming into it. Again, there are speakers later in the program, I think, who are much more better suited to talk about the innovations here. From my point of view, I just wanted to highlight that if you apply standard tests, preconditioning tests, that looks sort of after pre-con, virtually nothing changes. It's completely okay for that kind of modules. But where it gets inlated, you all of a sudden get a large spread in different technologies. Also, mono is not unaffected and multi isn't unaffected. Both sides have the problems with lated. And also there is quite a significant spread between individual modules, which goes back to my main thesis that we cannot live with two samples being tested. That doesn't give us the information which an installer would need for a warranty prediction or a system energy loss prediction. So we need to become a little bit more intelligent here. So, but where we see really the biggest issue is, that was earlier this year, we've shown that the hotspot doesn't become is no longer a hotspot, but now is a, well, hot area test. So it's not the traditional little pinpoint which burns, but it's now a module which is a cell part which is beyond 150 degrees. Beyond 150 degrees means we're going beyond lamination temperature. So we're changing something in the polymer here quite drastically, and how that behaves in long-term stability, this is an open question to me. Okay, so much for innovations in the module side of things. But then moving on to the more colorful and wonderful things in the building integration side. I think building integration is a future market which hasn't moved that quickly, but again, it has been exceedingly innovative in the last years. I just to show we're starting to hide the PV, which architects love. We're losing a little bit of efficiency, but I think for a bespoke system, for an architectural system, for an artistic system, this is entirely sufficient and good. I just show a photo of colleagues of mine here from the Fraunhofer ISE, which have a wonderful method of just hiding the materials, the PV string actually behind a butterfly-inspired color screen. It looks fantastic. It has wonderful colors. And again, the drawbacks are relatively minimal. The way to get color into the materials can be manifold. I mean, you could have it inherently in the dye if you have dye sensitized cells. Downside is that maybe your efficiency has a relatively low starting point, so this may not be ideal. More commonly, it's hidden either in an encapsulate-based or coated material, printed or specifically finished on colored front glasses. That could also be. A thing which is for us really important is in certain circumstances where you have historical buildings that can be that you need to have tiles which match the historic look of these devices, and you can show that very nicely, do that very nicely as shown with the terracotta roof tile from Megasolar on the bottom there. Or you could have these balcony kind of systems from Soltec. All these are visually interesting and intriguing examples, but you see not enough of those at the moment. Another topic which comes up is that we have lightweight modules. Why? Because many roofs are very limited in the carrying capacity they have. So if there is too much of a weight, or even worse of an uplift, because that tends to be on most industrial roofs more of a problem, then we cannot have PV on industrial roofs. And it would open like a tin of sardines, which isn't so brilliant. So lightweight modules, which are either structurally or flexible, structurally supported or flexible. I've shown an example on the bottom right, which is a Sunman, stole from the web pages. On the top, there is a approach where we have moved all the stiffness from the glass into the foam. Yes, the foam is a little bit bigger than the thicker than the glass, but then again, we need to have a minimum mechanical strength embedded in it. With the flexible modules, you get that mechanical strength from the material you glue it to, and here it is all inherent in the device. But overall, the module is not thicker than a standard module. It just weighs half as much or thereabout, or even less. So we open a large market here. It's very innovative. The weight also promises lower transport costs. If you have something like Sunman, you also have much lower transport costs because you can stack it much tighter than any other module you have nowadays. Again, there are thermomechanical differences, and I think everybody who's ever looked into developing a polymeric material module will see that there are massive differences thermomechanically. And always, from my point of view, is flexibility a requirement or is not? I think while you need to have your structural strength, you need to have one way or another. And then it becomes a tricky question where it stops or where starts the PV module. So BIPV is a super exciting market from my point of view, but it does seem to fail to increase in market penetration. So why is it not taking off? Just some food for thought here from me. It has two major issues in mind. One is cost, that a typical BIPV project is about 3 to 5 times as expensive as a normal domestic building applied photovoltaics project. And there is the problem that we don't meet standards. And with the standards, I mean don't meet PV. We meet PV standards, but not building standards. And mating those two standards is actually quite tricky, quite complicated. And we don't end up having, we don't have an appreciation as PV people for the building standards. I would say as a very big generalization. I know some people might feel differently. For me, the most innovative solution would be to be boring and mate those two together. We use building standards, and those standards we use to reduce the cost of our innovation. But again, it doesn't sound very innovative if all of us make exactly the same, but I think that would be one innovation in itself. So the last block of my presentation, the last 5 minutes, I just want to quickly go through the new applications which I see coming up, which where there is a little bit of, well, not a little bit, there's a lot of fun to be had with different shapes and colors and so on of modules, but also there's some pitfalls which I would quickly like to highlight. So I talk about ViPV, which is vehicle integrated PV, agri-PV, agro-photovoltaics, and floating PV, which are sort of, I think, the 3 big blocks which we discuss at the moment. The ViPV, again, can be very versatile. On the right, I show you a camper van, which we've done here in-house. Oh, not we haven't done the camper van, we've done the PV roof there. Then in the middle, there is the Lightyear 1, which is an electric vehicle where the solar cells are in there to enhance the range. And then you have a whole range of sonomotor vehicles, which again, you have either a range extension or you have cooling requirements or air conditioning requirements as for the commercial vehicles there. So there is the obvious question, which again, for something like the Lightyear and for the solar cars is quite tricky because you can't really predict the yield. I mean, in an extreme case, the car is in a garage, and so it doesn't really get you any production. How do you integrate for that, and how is that useful? The integration is difficult because we have to adhere to the behavior in the car manufacturing plants, which can be very different to the way we manufacture solar modules. And there is a whole host of typical processes which actually shouldn't be done with solar cells, which need to be considered. Reliability, again, you have vibrations going along all the time. If you lose your contact points because of vibrations, or if you start building up arcs, which is also not very useful or good for the long-term reliability. So again, there are some issues. I think they're all controllable, but they need to be considered right up front. In the agri-PV, I think this is, from my point of view, the top right, the vertical installations. This is a wonderful example of how things could come out of new module types, because we have now bifacial modules. And this kind of approach allows us a dual use of the land. It potentially integrates much better with the power system, and it makes use of the most innovative technologies we had last year, which was bifacial modules, or the year before last, but gives it a real meaning for this. Again, I'm quite happy to talk about in more detail about why I think this is better for the network, the power network in this sense, or why I see a huge potential again in space use here, because again, where we live here, we have problem finding land which is suitable for PV at the moment, because legally we're not allowed to use farmland. But this way, this could all be used, and this looks very promising. There is an innovation to be had here, because we need to change the way we route our cables. We need to make sure that a lawnmower or whatever you run through doesn't hack through, or a plow doesn't hack through the cables. And also there is innovation in how to make the most out of bifaciality and so on and so forth. But as an application, I think this is super exciting. On the bottom, I show you the more traditional BIPV, agro-PV approach. Again, we have here built over the farm, we have this kind of PV system, which may or may not sit on a tracker. But also there is innovation to be had, because you don't want to have as high a packaging density of cells to module as you have in normal modules, because actually it could be quite beneficial to have a glass strip and enhance transmissivity of the modules. So there's a specific type of module which is required for this. So, and then floating PV, which is sort of the last glimpse of it. From my point of view, where I'm living in an area where we have a lot of open mining, largely lignite, which we're supposed to close. And all those lakes which are created to refill the mines can't be used for anything sensible. So why not use it for PV? That's one thing. Why can't they use it for anything sensible, or like leisure or whatever? Simply because for legal reasons, there needs to be a certain minimum standard of water quality, and that is normally not met in a newly refilled mine. So it needs to be undergoing a 20-year renaturation program. And in that time, we would have plenty of spaces. Other countries have other drivers for floating PV, but again, it's finding space for it. Again, we need to have a different mounting structure. The mounting structure will have a different twisting on the modules. The different twisting on the modules will cause all kinds of thermomechanical issues with it. Just as one thing. And we have a higher humidity than we would have otherwise. So there's also another issue with that. All I want to say, it's a very innovative area where we have innovations in the mounting systems, where we have innovations in the way we design systems. But again, Ceres has written a whole host of interesting questions, what they've seen in their test field. Okay, that was in seawater. But for anybody who's interested in the pitfalls of a new application, I would recommend the Ceres work on the reliability of the floating system. So with that, I come to the end of my talk, because also I'm coming to the end of my time. I see the main driving this year's innovation largely happening in the cell size and in the interconcepts, and maybe the phasing in of new cell technologies. However, the quality of these innovations, or the longevity of these innovations, or the success of the innovations, will always be down to the reliability and durability of the issues. Again, that sounds always so big, but there was a really extensively tested, very innovative backsheet material called PA, polyamide, which was commercialized by Votorantim. And unfortunately, despite all the efforts to do all the tests and to do everything right, something new popped up, and they ended up, well, not being in business anymore. And that's the extreme case if innovation goes wrong. I strongly believe, from a modules or from a systems point of view, there is as much change in the industry as there hasn't been for a long time, or I would actually say never. The speed with which forms and shapes change is, from my point of view, breathtaking. And it brings a lot of smallish issues that frames have to be, or mounting structures have to be redesigned. Actually, inverters can't cope with the currents very well we have at the moment, at least for smaller systems. So there are a lot of interesting features on system designs this goes into. So with that, and there are many interesting reliability features which keep people like me employed. And with that, I would like to thank you very much for your attention and finish here, and I'm available for a couple of questions.
Super, Ralph. Thanks for this nice overview. I think there were so many questions. So maybe if you have a little bit more time after you answer here some orally, it would be great if you could answer also some in the chat. But maybe let's take two that were asked, and I found one interesting from Imco, who asked about hotspot temperatures exceeding lamination temperatures. So how could we control the operating hotspot temperature in the module below laminating temperature, or is it rather about using high temperature performance polymers? So what would be your answer here, or your solution to about that issue?
Before the first starting point, I would like, before I change anything in the product, I've shown you a feature or an observation. I haven't shown you if it is a problem or not, because I simply don't know. That would be, from my point of view, the first test I would like to do. The second is, if you increase your number of bypass diodes, your temperatures will be lower because your driving force will be less. And yes, or failing that one, well, maybe it would be a good time not to use EVA, but another material or something which can hold the temperature better. But from my point of view, this may be generally not a bad idea anyway.
Okay. There was also one question on ViPV. Someone mentioned that the challenge is also the warranty of module manufacturers' products for mobile devices or cars. I know the car manufacturers have been very picky. I think that was also the reason why in the past only few had solar used in their sunroofs. I think Audi was one of them, and it was very difficult. But do you have because since you also designed this little camping car and attached a solar module on that, do you have any experience or knowledge about warranty for that?
But the warranty is not what we know it as a PV company, I would say. As a PV company, we're interested in the power or minimum power we can get out of the module. A car manufacturer, for example, will be very picky about color trueness, or an architect will be happy for that. But it's surprising how much emphasis car manufacturers put on the color of their cars. They test car paints longer than we test PV modules by a factor of 5 or 10. So there is also the safety issues are completely different, because, well, you don't want to have some 20+ volts or so sitting on the metal frame, and all these kind of things are very different, and they're much more stringent than what we're used to be in our typical application. So yes, I would entirely agree. The good thing is a car doesn't need a 20-year warranty. It's quite happy with a 10-year warranty. But the car industry is also very interested in show me why it is 10 years, and not because you've passed IEC doesn't mean you have 10 years lifetime experience. And you have, because you pass IEC type approval testing, your module has a 20-year lifetime. I think they're not as easygoing as that.
Okay, maybe a follow up on that. Also, I think we touched upon that also recently in our reliability event a while ago. But I think one question was also, and you mentioned that also, what about standards and testing? Is it good enough what we have? Because I think some companies like, you quoted also PVEL are offering different set of tests, so that you have to use the same modules for various tests, and or are we in general okay with what IEC is doing for the industry?
The IEC, okay, I'm a module person, so largely I focus on that, but I think it translates to others as well. Is the most successful test in terms of reducing failure modes in industry. So whatever I say, which sounds negative about what we do in the IEC, always see it on the premises that it really is a super successful test. So there is nothing wrong with it. It's a necessary test. It's not a sufficient test. It's the baseline test where we see and test for certain basic failure modes. Unfortunately, some of the tests are done to be passed and not to show weaknesses, and to be passed at a reasonable cost. I sit on the IEC board for some 20+ years now, so I have been involved in most of the writings, and the debate is very often, well, when we had introduced a new test, there's very often the debate of, oh, we can't pass that, so we just need to find a way of making that possible. We can't just condemn all the modules we have on the market. I think it's absolutely important to do that, but we need to step back a little bit and just also try to understand what makes the module work for the long time. We need to look at new materials, and we need to look at the variants we have. As an industry, we test 2 modules in IEC, and then we say the whole type will be reliable over the next 20 years. And that isn't really true. And also, when we have new materials, we'll find new surprises. And that the IEC only tests for known failure mechanisms which happen in the first 5 to 10 years. Everything else, I don't think so.
Okay. Thanks so much, Ralf. And again, if you have a little bit more time, I think there's many questions. It would be great if you could answer some. And also to the others, I've seen actually there's a lot of experts in the audience from various fields. So if anyone feels she could answer a question, please actively participate in the chat. Once again, thank you, Ralf, and we continue with our next speaker.